Happy Easter and Christos Voskres to everybody concerned. And I realize it's Easter, so there's not going to be a lot of us today, probably, because some of us are celebrating Easter with the families and things like that. But anyway, I decided I'd stream because I wouldn't be able to stream next Sunday. So I'm trying to stream as many Sundays as I physically can do. Let me know if everything is alright, and let's get started. I'm gonna start with the slider today with some special effects. I'm gonna try to rearrange windows, and I'm gonna post the URL to the original website by the amazing agency Idea. There's a lot of cool effects on this website. Actually, the whole website is pretty cool. I think it's been featured on awards like a year ago. So awards, Kaide, yeah. What's with the internet? Okay, the Google finds something weird actually. Anyhow, can do it like this. Yeah, so this is the website. I'm gonna post the link to the chat so you can enjoy it yourself. And then we're gonna get started coding. Morning, guys. All right, here's the link. What do we do? Okay, change the setup to the default. Close these, pop up the chat. Gotta automate this at some point. Pop out chat. Okay, it's always the other way around. All right, this. And like this. I gotta disable this automatic feature. Anyway, this is the website. And let's just go to the, okay, I need the wider screen to see the effect, I guess. No, even wider one. Here it is. So I wanted to show you how to create this slider, but this time we did some similar looking things in the past. Similar but different. But this time I wanted to show you how we could use three.js new post-processing timeline and use TSL to create, basically it's all about these edges, the curves, and then make it loop and things like that. Whoa, Australia. I think, well, it's pretty rare occasion that somebody's watching me from Australia, so good. What is it in Australia actually? It's probably night, right? Something like that, like the evening. Hello everybody. So let's get started. Actually, this website is pretty cool for, well, numerous reasons. First of all, it's cool looking website. This is some old project here. I'm gonna create folder and then explain you. So I'm gonna call this one Kaida. I'm gonna get my usual template. Where is it? three.js start. The one that you could get on Patreon with any of the projects or just the bare-bone. I'm gonna go to the Kaida. I'm gonna do npm install everything. 6 p.m. Well, it's not that bad actually, because I think when I stream, there were some viewers from Brazil, and it's 4 a.m. in Brazil or something. So 6 p.m. is actually much better than 4 a.m. Okay, I have the cursor. Now I have to just start it. Right. Yeah. So now we got the simple demo. Like the first thing I want to explain to you why I assume this one is cool. Like you could see that there's a lot of videos, and every single slide is actually a video running on the background. And I thought, like, well, the obvious way to do this is to actually have like 5 or 6 videos, but this is actually not the case for this website. We only have, I think, one video, an MP4 or something. Where's that video? It's all, and it's, am I looking at the right website? I do. Gotta be a video somewhere, right? Where is it? PNG, JPEG. For whatever reason, I don't see. Am I missing it somewhere? So just JPEG and PNGs. Check WAV files, CSS, and COM. What the heck? I swear I saw the video here. Anyway, I mean, this is weird, right? Maybe they have like MP4 somewhere here. No, not linked. I saw it in the network tab. I mean, I can see the video, so it should be in the network tab, right? This is weird. Okay, maybe there's just a URL in the home. Yeah, something like that. I can just grab it from here. Sure, the live will be available as the recording. So I just wanted to show you how the video actually looks like. No, what the heck? Anyway, the idea is this is just a single video. Like this is Kaide. Like they don't have 5 or 6 videos. They have a single video sprite there. And I should have just saved it, right? Network tab, filter. Is filter somehow working? I don't know why. Maybe you see why I don't see videos. Anyway, so all of these videos are packed in one video atlas. And so it's basically one huge video with all the videos in between. So I think they had to make all the videos of the same duration for that, because it's basically one video with just small windows for each of the small videos. But it's pretty cool technique, right? Not really something you can then add in the WordPress or CMS, because it's just video and you have to go into the video editing software to get the video. But it's pretty cool that they actually did this kind of optimization when you know that you exactly have, like, I think they have 6 slides here. So for just they basically made 3x2 video atlas, and that's it. And they only have one video for the homepage, and it loads fast. And once it plays, every single slide is playing then. All right. Let me check. Sure, the replay will be available. But let's get started. I'm going to be using WebGPU today. GPU, and for this I would need to change. I don't really need all of this. I would need to change webgl renderer to WebGPU renderer. I think they also put some warnings for the render async. I don't need the uniform. I don't really need lights today. I don't really need this material as shader material, because there is no shader material in WebGPU version of the three.js. So because shaders just work different way. And what I want is like new 3 mesh normal node material. I believe this one should exist. And I think the slide proportion that I prepared was something like this. Hello Joshi. And well, let's see. Right, so we have the slide. It is already being rendered with WebGPU. I'm gonna just add a little anti-alias here. I think the transparent true thing. I also wanna move camera away a little so I can see the whole slide. Yeah, let's make the background black. Okay, get in there. Now, do we have wireframe here? Yeah, we do. So this is how the slide look like. I also have 3 Easter theme textures, which I'm gonna add here immediately. And I'm gonna get these textures. Hello to Vietnam. We have some geography today, like Vietnam, Australia. Let me know where you're from. Maybe like we have the whole time zone, I don't know, combo. Or how do you call this? I just wanted to get all the textures, like T1 from one spec and the rest of them. I only have 3 though. Okay, let's just load them and let's just test that we can put the texture on the mesh and then get on with the curved slider and all the special effects. Just we need to have some basis first for this mesh normal mesh basic node material. Basic. Maybe three.js should work on this naming because it becomes pretty long, like mesh, basic, node, maybe some other word we'll add in the future, and then material. Anyway, at least it's clear what's happening here. So let's TT1 because it's going to be already a texture. And I think we should also... what the... I wonder what that means though, and why Cursor's is trying to do this. But anyway, I'm just gonna... I don't know. Why do I wonder, actually? I can translate why Cursor is speaking to me with Chinese. Well, okay, English. Well, yeah, I guess. Was pretty obvious in the first place, but then doesn't matter. Okay, we have the texture array. I think I also wanted to activities for each, yeah, sRGB. And then mesh basic normal, I can just put the texture here. Let's see what's gonna happen. Okay, yeah, we can basically see the texture now, except for the wireframe thing. Right, so it's working, and the colors should be the same. Yeah, the colors are correct. I'm checking this because it's sometimes I just mess up the sRGB thing, and then the image would look lighter or darker or any other effect in between. But this time we got it correctly. So we can continue. All right. What's next? Now I need to create a couple of slides, obviously. So let's say we have, I don't know, 6, 7 slides. How many do we actually need? Maybe 6. And hello to Kenya, yeah. Well, we have some... We are missing 2 continents, basically. 2 Americas. And... slides, yeah. So let's say we add in the object here, geometry we have. I don't need to add this one mesh, but these slides. And then inside this array and this, let's say 6. On each slide is going to have this material, but with a different texture, right? So probably I'm going to do something like material, this material clone, and then map equals tt's I3, tt's length. Yeah, and this should give me a different kind of textures. And then this slides, I'm going to create it as an array and a useful array. So it's going to be mesh slide. Index is going to be I. And for now, this is drawn here. Push mesh slide index. What's wrong? Oh, because I have mesh or what? I don't really have mesh. Some syntax thing here happened. Where did I mess up? Okay, maybe I can basically do it slide as well. Yeah, and then index is gonna be I. What's wrong again? Unexpected token. Oh, because this is an array already. I need an object, not an array. Why do I? Yeah, was a yeah. But today we're gonna be doing this effect with the TSL. So I'm gonna show you how the pipeline works with the TSL. Okay, what's wrong now? Okay, we have the textures. Now I basically want to shift each texture by 8. So I have them, so slide position X is going to be, well, the cursor is proposing something complicated. Maybe it's correct. No, it wasn't correct. And it wasn't correct. Okay, so if you do it like this, I should get slide position X I multiplied by 8. Should have got it correctly. Oh, I just needed to refresh. Yeah, so it is correct. So I got kind of the infinite slider. And then I want to add the npm virtual. Do I need it at this point? Okay, let's just add it. It's easier to debug with this one. And then just copy paste this. And then I want to have the variable which is scroll position, which equals 0. And in here, I'm just going to update scroll position with event y, probably multiplied by something small. And then once I have scroll position, I can then iterate every single of my slides and do something with it. So right now, do I have actually, let's output the scroll position. Don't need this. Yeah, so we can scroll, it changes the values are relatively small, which is what I need. So now I can iterate my slides. I can also save original position. And this is going to be just the slide position X. Just the value that I calculated here. And then I could actually subtract something so we're like looking at the middle. What? Yeah, because I started and I never finished this. Yes, now we're looking at least at the middle slide, at the middle of our small gallery. Nice to see you all, guys, and thank you for the kind words. Nothing warms up me more than just the kind words of people watching me from some really distant locations, which I'd like to travel at some point, of course, when this whole shit war is over. And then have a regional position, and on each change of my scroll position, I'm just gonna change the what I have here, slide. So it's gonna be probably like object, and then the object slide mesh position X is going to be object original position plus what? Plus scroll progress. Oh, how do I call scroll position? Okay. Okay, it does work, but I need to disable orbit controls. I also need to disable the scroll jump. Our scroll. Yeah. So now we have kind of a slider, which took us like, I don't know, 10 minutes to create, almost infinite. We can actually make it infinite really easy, but there's a couple of issues here. So it's quite interesting that in the original website, like the way I do these curved sliders usually is inside the shaders. So I'm just updating the vertex shader for the material and I create this curviness. The way they did this, they kind of used both. They used the shader and then they used the mesh, the actual mesh position. So they curved the actual mesh position. Just so you understand how they did this, because I just wanna kind of show you the idea. It looks pretty cool. So we have we have the update here. So I want to create like a big circle. So the radius is going to be roughly, I don't know, 12, 15 maybe. We're going to increase it. And then the distance to camera, I think it was 8. Yeah, so the dist is 8. It's just going to put this dist. And then I want to move each of the slides on this circle, actually. So what I'm going to do is I'm going to first calculate the angle. Angle is going to be actual mesh position X, like this one, but multiplied with some small value, and then probably need to rotate it by the math pi. So I don't know, maybe 0.1, let's say. And then the X and Z coordinate is going to be calculated as this, but with the radius. With the radius, yeah, not the dist, but with the radius. And then I can calculate the actual mesh position object. Yeah, it is actually already here. Object mesh position set. So even though I'm kind of setting the position first here, I'm gonna rewrite it here, and let's see what's gonna happen. S is not defined. The hell is S? No idea. Okay, kind of want to get back with orbit controls to see this whole thing in perspective. Yeah, see what's happening. So it's when I scroll, the objects are actually rotating around the circle. If I just disable for a second the scrolling thing, you could see that all the meshes are like located in a circle. But we also need to rotate them, and we can do just object mesh rotation set, and then which one? I only need the Y rotation probably. I think it's gonna be the but I also need to rotate it back again. Okay, let me disable orbit controls again. Okay, the angles are not right for now. I think it's gotta be 0.5. I also want to make these meshes double side, so I want to create this material, double side material. Kind of getting there, right? Still not. I also think that this angle is gotta be also shifted by the... Yeah, so we are looking at the first slide. Yeah, and now you see we're getting there. So we actually created slide with simple trigonometry. You can argue with simple, probably, but it's still trigonometry. So I can change this probably, and at some point I should get it right, like this, for example, right? So now we actually created slider. It's a bit more complicated to make it infinite because you would need probably to move slides from the beginning to the end, but it's enough for our purpose today. So there's actually a couple of streams where I created the true infinite sliders. We can actually calculate the number of slides and cover the whole circle. That would also be pretty cool. Like you can calculate if you have 8 slides, what's going to be the slide size so that the 8 slides could cover the whole circle. It would be some octagonal geometry probably or something like that. Oh, salam alaikum, cybernetic. And thank you for the kind words, guys. All right, so this is one way to do this. The other way to do this would be like if I just disable this for a second, we're gonna get this, And I can do mesh basic node material. Where's that? Where's my basic node material? And I can do this material not on before compile, but position node. Going to be fn. Also need to run it immediately. I always forget to do this. And then in here, if I didn't do any errors, and I did, is it position node actually? Is it something else? It should be position node. What's the error though then? Because it doesn't return anything. So just position local, I think. XYZ. It says so we can update it, and then I can return this default position. I believe it's because I'm not returning anything. Right, so now it's all correct. We kind of wrote a basic vertex shader for this material. And this means what I could do. I don't really need the fragment shader for this thing, to be honest, because all the effects would be created in the post-processing. So I only need the vertex shader, but I can update in the vertex shader stuff. So first of all, I'm going to calculate position world. It's going to be the model world matrix multiplied with position and with local position. This will get me the world position. Now, depending on the world position, I want to distort the geometry of my meshes. And by the way, I'm going to increase the detail here. By the way, why is wireframe not working now? Wonder. Just enabled wireframe. Okay, those are mystic things happening during the stream. Anyway, so let's continue. And so for example, I can calculate the distance from the center. Then distance from center is going to be length, position, world, x. I'm only interested in x. And then, well, it's basic. I could have just used this, right? And then position y, I want to multiply, do mul assign, float 1, add distance from center. And we get something like this already. But it's because this is a linear thing, and I would probably want to make this, I don't want to divide it by 12. And that's going to be really cool. I mean, yeah, these are shaders. And then I want to power this to the second and maybe multiply it with something smaller, really. Something wasn't right. Maybe multiplying wasn't quite correct. Maybe I don't have power. Yeah, just don't have power. All right. Kinda better. Probably now I have to do this multiplication. Yes, now we're getting this curved slider. It actually works pretty cool. I mean, it's not as cool probably as when the whole slide is being rotated, but I guess it depends on the look that you're trying to achieve. If you get back to the Kaida, it actually kind of looks like it is curved exactly like that, right? But funny thing, it is not. So all the slides have straight edges, and the curviness comes from the post-processing. And well, I guess we come to the post-processing part. So let's see how we would use post-processing in here. I'm gonna call this function init post. Okay, let's call it init post-processing. And then these are my slides. But you could see, I hope you get the idea how you can improve this thing and create almost anything with this combination of shaders, but this time with WebGPU already, because we are using shaders. And it's so much cleaner, to be honest, because I have all the math distorting this whole curvy slider like right here in JavaScript as horrible that might sound, but it's just a couple of lines. All right. Let's get back to the post-processing part, the most complicated and interesting thing in here. Let's create post-processing. Like, the thing about new technology, Cursor doesn't really know what we are doing here because we are already in the WebGPU context, but it's still trying to get those things from the like WebGL perspective. And but it is not. So we're going to be using something else. So first of all, I'm going to initialize post-processing. Let's just create a simple setup, and it's going to be new 3 post-processing, and then we have to use the renderer. It still tries to go the WebGL way, so it's going to be a bit more complicated with this than with the WebGL, because with WebGL, Cursor pretty much can write code for you. With TSL and WebGPU, not yet. What else? So now I need to get the default rendering of my scene. So it's going to be let scene pass. It's going to be pass, and then in here it's going to be scene and this camera. And then I can actually output it later on with my post-processing. So this post-processing is the same node-based thing. So did I use a capital there? No, I did not. This post-processing output node is going to be scene pass. So let's say nothing should change really. And let's try this. So instead of running the renderer, I'm going to run the post-processing render async. And well, nothing changed. But now we have the access to the like render target of this thing, and I can, for example, multiply it with 0.5. Yeah, and you see that we have the control over like computational power over these post-processing steps. Now, what else can we do here? If you go into the GitHub, Mr. Dupe, and hello to Mr. Dupe for this amazing work, kudos to him. And then examples, and to all the contributors, of course, not to undermine anybody's efforts. You go here, there should be TSL folder somewhere, right? Or am I hallucinating? No, it is here. You go into the TSL, there's a couple of useful things, and I remind you, this is the examples folder. So this is not particularly part of the three.js core. It's more like a useful things, which is why it is always useful to look in there, because there might be something useful for you. But then if you look into the display, there's plenty of passes, which are similar to the one that you had in the post-processing, in the usual post-processing steps. Like there's the anti-aliasing, dot screen node shader, and stuff like that. And what I'm interested in here, I have a couple of special effects to use here. I want a Gaussian blur. Yeah, it is in here. So I'm just gonna import that one. Do I have a pass actually here? Yeah, I have a pass and I'm using it. So I'm gonna import Gaussian blur node from the examples, GSM, TSL, display. It is like that. Is everything all right? No, because TSL display Gaussian blur node does not provide Gaussian blur node. What does it provide then? Just the Gaussian blur, probably, not the node. Let's see. And what is it? Exports. What's the export? Yeah, it exports not the node, but just the Gaussian blur. Yeah, now it is correct. And the nice thing about all of these nodes and stuff like this is that right now, because previously you would need to connect the passes and it was kind of a black box to you. But now I feel like I have more control over this whole post-processing thing. And where is it though? So now if I go here and I just apply Gaussian blur, and it takes 3 parameters. I think the second one is the blur radius, and the other one is the amount of the iterations, because this is basically a loop and you sample texture a lot of times with some randomness, and you're gonna get this. So we immediately got the blurred version of this thing. So I'm gonna just save it as another texture. So like blurred pass, maybe. This is gonna be this. So then the normal pass is gonna be just the scene pass. And I can, for example, do I can just mix them and see how we can create fake depth of field effects in here. So it's gonna be blurred pass, normal pass, and then we're gonna use the screen UVX, let's say. And mix is not defined. Like wish it was automatic. All right. So now we're kind of getting into blurred version of something, and then I could. I just don't like how this looks like, because I don't know. Maybe it's fine. It's actually blurring this stuff when we go to the left. Just maybe edge is going to be step, and then screen UVX, and then edge. Yeah, just so we could see how it actually, the edge is being created. And of course, if I increase the amount of passes, I'm going to lose performance a little bit, but I'm going to get nicer blur. And I think this is also too much. Maybe just one. Maybe even less than that. So now we kind of get into the normal blur territory, because it was a really big blur, and for that kind of blur we would need a lot of iterations to make it look smooth. But for small ones, you could see that we are blurring the images when they come to the left. Anyway, why am I doing all of this? Is because you could see that the images are getting blurred here on the edge as well. So we need a couple of textures to do this. And the other textures that we need actually is to distort the UVs here, because you could see that on the edge here there's a really nice distortion, and it's kind of living its own life, right? It's both pixelized and also kind of wavy. But the thing that I'm most passionate about all of this is how, I mean, we will do this math right now with the UV distortions and stuff, but just how simple this looks like, right? And it's JavaScript function. It's not even a shader like in the common sense. It's just some couple of JavaScript lines where I'm actually working with all those graphic pipelines, because obviously this is made with shaders and WebGPU backend, but we are controlling it via just simple kind of function like programming here, like node-based program. I don't know how to call this. Anyway, so we're just throwing the nodes here and there and applying some effects to them. Yeah, my course is basically applicable to the people who just start three.js, because I explain all the basic stuff in the beginning. Anyway, I'm not stopping for too long on that one, but I'm starting with just basic stuff. Yeah, shader. I think it's, well, my course is nice to start with shaders. Bruno Simon course is also nice. Nick's course is also nice. I believe people would share with you all the nice resources. I'm not in any way like advertising myself. There's a lot of really nice people who create cool tutorials on shaders, and I love all of them with my heart. And then, because I'm all for popularizing the good knowledge. What else? So what I want to do, I want to create a couple of these versions of this render pipeline, and then merge them with the mix functions, just so we get this effect of kind of, I don't know, depth of field, wave, fog. I don't know how to call this. Anyway, so I don't know if you knew, but there is a noise function in the shader. What is a poutine? I think I forget this word. What does it mean? Well, I'm not sure I can make this. I hope you didn't mean the other Putin, because I wouldn't like to make him. And then let's get on with it. So I want to apply the noise. We have the screen UVs, which are usually, I can make a debug thing here, screen UV, and let's just see how it works for us. So basically have the UVs in this variable. I also have the mix noise float, I think, a mix noise float. Yeah, this is the thing that I need. And let's see. And let noise UV gonna be screen UV multiplied by 10, and then noise is gonna be a mixed noise from these noise UVs. And let's debug this noise. So we have it. Now I want to add time here. So let u time is going to be uniform 0. I want to expose this time uniform is going to be u time. And in here, I want to update my time. And this means that when I'm creating here noise UVs, I can just add u time here. Yeah, and we pretty much have something already, but I want to play with UVs a lot more. So I'm going to create a separate function, const process UV, which is going to be a fan, and noise UV is going to be process UV. In here, it's going to take UV, and in here, I'm going to be using screen UVs to apply this function, right? Am I doing it correct? I don't think I need to put the array here, right? Only when I declare the function. So this is it. It should be. Do I need to correct this to a variable actually? Oh, hello to Ukraine. Yeah. So I think I need to convert this to var. It's still kind of shady territory for me too, but I think just not to update the original screen UV, I would like let new UV to var, and that's new UV. Okay, nothing actually changed. If I change this variable, yeah, I get it. So it is working. So because this function is gonna have like a little bit more stuff inside, so that's why I wanted to kind of create a separate function for this one. Now there's got to be a little bit of math, and it might be not clear at the start, but then we're gonna get there. So first of all, I'm gonna normalize the UVs. So I'm gonna sub 0.5 and probably two-dimensional thing. I'm not sure if it's probably gonna work with just sub 0.5. Okay, I'm gonna normalize it, and then at some point I'm gonna bring it back. So add a sign, yeah, and then in between I'm gonna do something. So now I lost the multiplication part, so it's only oh, I remember who are Yukin Himura. Okay, let me do this. I remember that you always been trying to be toxic and get into me. Not gonna happen today. And then what else? So now we got this, and in the middle, what I want to do, I want to make this symmetrical, and I want this to spread in different directions. Because in the end, just answering this Himura guy, we basically can apply all of this into the React Dry too. It's just that This is a more advanced way of using post-processing, which is not yet accessible in 3.dry. And I would say this is the alternative way, because React 3 fiber and dry method is always also nice because it's like declaration wise. But this one is also nice. It's just an alternative version of how you could apply all the functions to one node and get something in the end. This gives you more control, I would say. And then let's get with business. So first of all, I'm going to shift the noise UV on the X just to spread them on the other side. I also need the sign function while I'm here. Sign function. And then to do sign function. I want to add to my UVs. So new UV X adds a sign new UVX, and because it is sign, is going to be -1 on the left side and +1 on the right side. So we're basically adding a 1 and -1 to the different sides of our UVs. And the new UVX here. But I think it's got to be the other way around. It's got to be sub-assign. What we're going to get is two symmetrical sets of UVs. And why it is useful, because it will help us to stretch these UVs now. So it's not multiplied yet, so the noise is like whole screen big. But we're going to get there now. So in the end, I would actually, maybe here, I would do the multiplication just so we see how it looks like. Process UV, screen UV multiplied with 10. Oh, it's using screen UV, but not the UV I'm actually transferring to the function. Right, so this UV, UUVX. Wonder why it is still symmetrical. I wonder why it stays symmetrical. If I'm really kind of, it should not be symmetrical from where I am. But maybe it's because I'm bringing it back again, probably. Anyway, now the stretching thing. Now I want to normalize. That's a bit more complicated part because it involves some math which gonna stretch only the edges of this texture, both on X and Y. So I'm gonna try to write it from my cheat sheet and then explain. So first I'm gonna calculate some absolute value from 0 to 1, which runs from the center to the side. So it's gonna be UVX sub 0.5 and then divide by 0.5, which basically gets me between 0 and 1 thing, which is running from center, and 0 being in the center. All right. So far, so good. UVX. And I'm using the original UV, which is still not normalized. So when I subtract 0.5, I get something between minus 0.5 and plus 0.5. All right. I could just probably even output what's happened. Apps is not defined. Okay. Apps. It's working. Now we get this edge somewhere, which is weird. Still no change for this. I wonder why is this like that. Anyway, let's continue. So let's bring it back to the 1. And now let's do the stretching. So I'm gonna just do, for example, new UV X, assign Can't I just do this assign? Yeah, so it will be symmetrical because this one is changing between 0 and 1 on both sides symmetrically. This is what I wanted. And now I want to apply stretching to the x. So it's going to be noise uvx. And then I want to multiply it with something. Okay. And in here, if I remember right, the numbers were like this. 1 sub, because if I multiply it with 1, it obviously doesn't change anything. But then if I multiply it with something below 1, it's gonna just stretch the UVs. Like, for example, I don't know, maybe let's put 0 0.5, 0 0.1, and it should be stretching even more. Oh, it's because I'm putting the new noise UV here, which I should be putting the new UV X. Yeah, so you see it's gonna stretch or contract the UVs here. What I want to do here, I'm just probably confusing the new UV and UV somewhere. And sub, and then what's there? I want to sub my new UV file to the. Do I need the file? Quite close, but a little complicated math here. So I need to subtract something from 1. And this should be dependent on this XX thing. Because not maybe particularly XX, but just the UVX coordinate. It's like this new UVX. And I want to... okay. Oops, no new UVX. And then this new UVX, I'm gonna power it to this something small. And then let's see what's gonna happen. Now I want to multiply this with something big. And you could see that we are stretching. It's just that we should be stretching symmetrically to both sides. So let me first fix this error in the beginning. Oh, I'm using add assign here, whereas it should be probably... it should be right. Okay, so UV sub 0.5. I'm converting this one to var. This is correct. I want to get back to symmetrical UVs here. So I'm gonna command this first. I'm gonna command this. X sub assign sign noise. All right, this seems correct, but then for some reason, maybe simplify this a little bit. New UV to var, new UV add assign, and then return this. Maybe I can also multiply this one with something here. Well, it does, but it should be, there should be divergence in the middle. For some reason there's no divergence. Why is that? New UVX sub assign. Maybe it will be created by the further changes. Anyway, okay, so I have the time here, right, at least. The time uniform is what I mean. And then this means that once I normalize it, I can try to, maybe the divergence will be created by the time itself. So maybe I'm just looking for something wrong. I don't really need to look for this then. So it's going to be new UVX add a sign. Here I'm going to use U time multiplied by something really small, probably. It's like something is inherently wrong and I don't get what it is. It's like, why is U time is not adding right now? It used to work for me, right? Just had it. Okay, this is too slow for the time. All right, this was too slow. Okay, this one is working at least. Then I want to move my time only in the correct direction, and then here probably UVX sub 0.5. Why is it 0.5? Why is it shifted like this? Is it because pixel density or something? And because I'm streaming now and the pixel density is changed. What is the window device pixel ratio? Device. What is this device pixel ratio actually? What is this shit? Like I didn't even know it could be non-integer. Did you know that? It's probably because I'm streaming right now, and this means that UVs are getting corrected. Aha. I don't even know how to autocorrect for these UVs now, right? This should be. It should be. This is why, because the UVs are not, the screen UVs are not correct, right? How do you fix this with non-integer device pixel ratio? The heck? Yeah, maybe I can just hard code something here. Why is it not moving? Like, why is it not changing? What the hell, guys? I'm just working with the screen UVs here, and then it all messed up somehow. Okay, UVs, subtract. Yeah, we can maybe, for the time being, remove this. Ah! So the noise UVs are not actually... Okay, process UVs. Here we have screen UVs. Let's multiply this. Just use it as is. All right. This is what I had in mind, actually. Thank you. And negate. Right. Getting somewhere, finally. This is what I wanted to do in the first place. Let's also add... Okay. Working... I don't even know what I changed. Probably the multiplication was the wrong one. Maybe it wasn't applied or something like that. And... yeah. So I'm just returning my code, actually. Yeah, getting somewhere. So you see that this whole reason for this whole code was to stretch this thing, and then I wanted to actually multiply it. Which part actually? I think maybe not negate then. And we could also multiply it by 100 or something. We could also make it less than that. And you could see that on the x-axis, we are now stretching our UVs when they come to the edge. Ooh, finally. Oh, hello to Panama. We actually got all the continents now because Panama is right in the middle of the two other Americas. Right, so now I also want to stretch the y coordinate, and then we're going to be ready to apply all of this to our noise UUV y. It's going to be assigned same logic, just different magic numbers, and float 1 sub 0.6, and we're going to multiply it with that xx raised to the power. Here is going to be xx raised to the power. Almost there. I think we need to kind of normalize this stuff. It's already looking pretty cool, right? But not white, right? So we're multiplying the y coordinate, but the y coordinate seems to be not normalized. And this is because I changed this part. So now it's getting normalized. So we're actually getting this nice effect. Yeah, well, I've only been to Panama for 1 hour, to be honest, in my life. But I wish I would visit then. Right, getting that. So this is pretty cool already. Now I want to also, actually we can already apply this effect to our noise coordinates. And so we calculate the noise here. We calculated the noise UVs. Then we're using the default function mx noise float to calculate the noise UVs. And then I want to use this noise now to calculate texture distortion. Right, because we have okay, I'm gonna collapse this. We have the blurred pass, we have the normal pass. We have the scene pass. Let's use it here. And I want to sample those passes with the UV distortion. And usually how you make UV distortion from the float number, you calculate the angle from this and then distort the texture by the angle. So to do this, first, let's use here the sample. So I'm going to use scene pass sample screen UV. Let's for the start just sample the screen UV and see if it's working. Doesn't. Maybe screen pass texture. How do you sample? Scene pass. I think it should be scene pass. Get output or something. How do you call get texture node? And then I should be able to sample this with the UVs. Yeah. So now I'm sampling this with the UVs. Now I could try. No, these noise UVs are actually just these noise is just a black and white thing. So I need to update my screen UVs with this noise as a distortion. And for this, I'm gonna calculate the angle. And the angle is going to be, what's that going to be? It's going to be noise multiplied by 2 pi, basically. So noise, yeah. And then the direction is going to be, yeah, cosine and sine from this angle. And then I'm ready to update my UVs and create the new UV, which is going to be screen UV. And then we're going to add direction multiplied with some small value. Probably right. And then I should be ready to use this new UV as here. And we get some pretty cool effect, to be honest, right? It's already cool. I mean, even like that. Now I should actually add a couple of things, right? I have a blurred version, and the nice thing about the blur is that I could actually use the Gaussian blur right here. I could just wrap it up. And you're gonna get same stuff but blurred now, which is so damn cool. Like you could just link all those node things and have numerous really useful shaders by just taking the input from the output and stuff like that. Like basically using nodes. Well, thank you guys. Thank you for the kind words. All right, so what's left is to calculate where is the edge. So I'm going to use this simple function for the smooth step thing. So the edge is going to be, and I'm going to just debug it. I already have the edge here somewhere, and then I could do the ups screen UVX sub 0.5. And let's see how this edge is going to look like. Should be just symmetrical edge 0, 0, 1. Yeah, this is what I had in mind, just an edge, and I'm going to use this edge now to mix this blur. So basically final UV is going to be mix between screen UV, new UV, and the edge. So I want to apply, I only want to apply this thing on the edges of the screen, basically. And I also want a couple of these edges, right? Because one edge is going to be for blur and the other edge is going to be for other stuff. So let's also create H1, which is going to be 45, which is just going to do it into the black. Just going to move everything into the black. And H1. What do I do next? I want to apply the final UV now and see how it looks like. Yeah, we got it, and it could be probably more. We could play here with these numbers, I guess. Because right now it's more like water-like, which is not bad. It's just the other look. We can also add the scale here, because right now in here we're multiplying with what? With 100. Multiply with 1000, let's say. We're gonna get this pixelized effect, you see? Which you could see on the original website. And I'm just gonna add scale here. And noise UV is going to be screen UV, and then, like, let's say 1. Plot 100, multiply, scale. And noise UV1 is going to be 10, which is going to be get me 1000 here. And noise 1 is going to be noise UV1, which I probably could just do the noise add just like that. Add a sign, yeah. Something went south. Is it this one? Yeah, but why? A mixed noise. Hello to Barcelona. I love that city. This is, some of the errors that you get with TSL are not quite clear. Like right now, I'm just trying to add a sign to this noise theme. Just basically add another value in there. Well, I can do it like this, probably just another variable. Let noise 1 is going to be this. Mix noise float, and then okay, I saved everything correct. I just want to get the pixelized look on the edges too. And noise add sign. Why doesn't it work? I'm not really sure. These are just two values. Maybe it's because it's not like var or something. No. Why would I get this error though? I'm not sure. Anyway, I can maybe just edit here, noise, add noise 1. Yeah, it's gonna work like that. I don't know. I'm honestly curious why it didn't work, because it was kind of obvious to me. And now you get this not only water-like but also pixelized-like effect. And we can actually change the amount of distortion here and get some pretty cool effects. And now I want to apply the other one of the last things is to apply the edge. So I'm gonna do the like that pre-final color is going to be yes, scene pass, and then pre-final. I have to learn these like the new routine on how to update the variables here, so I don't stumble to this. I think it was 2var, but it didn't really help when maybe both of them should have been 2var. I'm gonna try it after the stream. So this will be the mix between vec4 black, but not transparent black. And then I'm going to use the edge 1, which is the narrow edge. So it means when the edge is, should get me the black border, right? And then I can output it in my post-processing. All right, this is the other way around, but this is easy to fix because you could just add 1 minus. Really useful function in TSL. And you're going to get it the other way around. Well, the edge is too small. No. And probably this edge could be also used with some kind of noise, maybe, so it's not that obvious on how this works in there. So maybe also, I don't know, it's actually kind of look almost like the original slider. I don't know if we need to change anything else. Like, you could obviously play with these noise functions a lot. For example, you could change here, would change the radius of this one, and it will make it, I don't know, some cosmic kind of thing. I don't even know how to describe this look, but some other pretty cool looks, and you could achieve like almost any kind of idea in here with this one. And I remind you that we created this curvy effect with basically I also wanted to blur, right? And also have the blurred version and the blurred pass in here, and I wanted to kind of apply the blurred version to the edge as well. So pre-final color, and then super final color is going to be mixed. Yeah, something like this. But we're going to use not just the blur pass, we're going to use the Gaussian blur on this pre-final. Will it work like that? I just wonder. Well, it will, yeah. So now not only it's distorting texture, it's actually kind of blurring it. But maybe the blur would be nicer to start a bit earlier, so these effects combine better. But then I hope you, like, my main idea was to recreate the effect. You could play with these numbers a lot here, right? For example, also might change the edges and see what's gonna happen. It's almost like fake depth effect here. If you get the numbers right, so it kind of aligns with the curviness of the slider, you're gonna get the fake depth effect here. And maybe put it to the maximum on the edges, actually. And also maybe smaller things here would look better. I don't know. Just getting basically different effects depending on the UVs and looks. Anyway, my main idea is, guys, you see how it is super cool, even though complicated and error prone, but still super cool how you can work with these graphics now. So basically graphics becoming just the JavaScript variables, almost JavaScript variables, but then you could still like multiply them, apply them, chain some functions applied to them, like the Gaussian blur that I applied to one of my in the middle results, basically not even looking in those big functions and those loops, because Gaussian blur is basically a lot of loops and a lot of sampling of the textures. Should be careful with this number, by the way, but still, it's just super cool that this is not too much of a code for the so many effects that we did here, like the complicated UV's distortion, and then the post-processing part. Like this whole thing is actually post-processing. There's a lot of passes here right now, but we only see, I don't know, 15 lines of code, meaningful code. Whew. I hope you like this journey into three.js post-processing. I'm actually pushing myself into this because it's much easier for me to use webgl and GLSL coder, just GLSL code to create these effects. But I'm not gonna learn anything, and I'm trying to switch as much as possible to new web GPU routine with TSL shaders, and this stream is part of this learning thing. So I hope you learned a lot of stuff as well. Even the errors that I make. I hope they will be useful to you, because in the end, we actually made it right. I think the reason was using 2var, and the other reason was that we used multiplication in the wrong place, just multiplied in the wrong place. You have to always remember which variables are being mutated and which are not. And I'm going to end this stream on this note, and I hope you have a great Easter today. And actually made the Easter bread, so how do you call it, traditional one tonight, because I felt myself even more pushing myself to the challenges of baking stuff. I hope you're gonna do some fun stuff today too, but I always keep saying that don't ever forget to say that you love to the people that you actually love, because it seems like this is the only thing matters, the love in this world. So if you love someone, just tell them that you do. Even if it's, I don't know, your friend, your lover, your parents, anybody. And enjoy your day, guys. And see you in a couple of weeks, probably, because I'm going to actually have a birthday in a week. So I'm not going to be able to stream on that day. But after that, I will try to continue streaming more often. If you have any websites, send them my way. I'm going to try to decompose them, because this website I only received like a week ago from my subscriber. And I decided I should do a stream about it. It's going to be educational. So send them my way, put the comments, because this is driving this whole process of me. And